Hey guys, my name is Devin. I am an aspiring level designer working on some independent game projects, as well as working on my own projects and doing these tutorial videos for Kismet. And today I'm going to show you an improvement of one of my earlier tutorials about the automated turret script. With that turret script, the rotation of the actual turret itself is based on the rotation of the player. So if the player is rotated towards the turret is going to be rotated facing the player. So whenever the player is looking at the turret's going to be looking at the player. Now it's just an easy way to have it so it looked like the turret was always following you. It was a good tutorial. It had a lot of good information, but in this tutorial I'm going to show you how to make a turret that actually follows the player based on the player's location rather than the player's rotation. I want to give a nice shout out to Dom Ridley, who messaged me through YouTube, and then we started talking on email. He wanted to know how to do this turret tutorial based on the location of the player rather than the rotation. So I did some research and I found the solution. So I'm going to go over how to fix the earlier script so that the turret rotates based on the location of the player rather than rotation. But I'm also going to explain some issues you might run into trying to get certain meshes to rotate in the way I'm going to show you here. So let me first show you the script and let it run, and then from there I'll talk about how to do it from scratch. So I'm going to press play and we'll jump in and see how it works. So basically, even if I'm looking away, the turret's going to be following me and firing at me. And the turret's going to be rotating and constantly shooting at me, even if I'm looking away. And then if I get behind something, it'll stop firing. And then if I can be seen again, it'll start firing at me again. And if you noticed, I'm not using the same turret mesh that I had for the original script. I'm using a cylinder I created in 3ds Max. I'll go over how to make a cylinder too and how to have the appropriate rotation, because one of the biggest problems I ran into trying to get the old turret script to function the way this new script works is the static mesh that I used for the turret's firing mechanism. When I try to get it to rotate how it must be done in Matinee, the barrel of the turret doesn't face the player. It's more of the center of the object that faces the player. And I'll show you what I mean when we actually start scripting this. But for me to get this to work, I had to create a specific cylinder model and have it rotated in a specific way within 3ds Max in order for it to rotate facing the player appropriately. So let's start with a new level, and we'll start from scratch, and I'll show you how to set the level, how to model in 3ds Max, and how to export it and then import it into the content browser. So let's go up to new. Let's do midday lighting. So the first thing we gotta do, like always, is we gotta go up to view. Let's go to world properties. And then under game type, we gotta change default game type and game type for PIE. We gotta change both of those to UT game. And when we do that, we're basically telling the world info that, hey, we want to play this as a UT game kind of level, so we'll get the link gun and we'll get the ability to use Kismet and let it function properly within the level. So now that we have that set up, that's the only thing we got set up in the world itself. So the next thing we're going to do, I'm going to jump into 3ds Max. I'm going to create a cylinder, I'm going to export it and then import it into our content browser, and we'll change that into an interactor, and then we can start scripting. So let me open up 3ds Max. I have it open here. And if you haven't used 3ds Max before, I'm not going to really go over how to maneuver really. So if you want to watch a quick tutorial online to figure out the controls, how to move around and navigate, I'm just going to show you how to create a cylinder and basically how we have to have it set up in 3ds Max and then export it so that it rotates properly. So in the create panel here, we're going to have to go to cylinder. And then I'm just going to left click drag out a cylinder, just create a pretty decently big cylinder, and then let go of the left mouse button and then drag it up just to create a pretty tall cylinder. And then I'm going to press J to get rid of those brackets. And then we're going to go up here to the modify panel, and then all I'm going to do here is change height segments from 5 to 1. And then the next thing I'm going to do, I'm going to click angle snap toggle. So now I have snapped angles, so I'll snap every 5 degrees, I believe, is the default. So all I'm going to do is I'm going to rotate it 90 degrees, negative 90 degrees in the y-axis. And then that's all we really need to do for this cylinder. Actually, I'm going to make it a little bit taller. I'm just going to bring this to 192 in the height over here. So now that it's complete, we're going to go up here, click on this button, go down to export, and then I'm going to save mine to desktop. I'm just going to call it turret, and then hit save. And then the default export type is FBX, so that's what we want. And we're just going to leave everything at their defaults, so we don't want to change anything. Press OK. Now we can close out 3ds Max. I'm not going to really save this since it's just a simple cylinder. Alright, now back into UDK. Let's go into our content browser. And then down here, let's go to import. It allows us to import textures, static meshes, animations, things like that. But all we're going to do is we're going to find our turret FBX. I save mine to the desktop. So I'm going to open it. And for package, all you have to do is just create a new package. So I'm just going to call this turret tutorial. Grouping, I'm going to put it under static meshes because it's going to be a static mesh. And then I'm going to leave the name as turret. And then I'm going to press OK. And then it'll bring you automatically to your turret tutorial, or whatever you named it, your package. Usually you'll find it down here towards the bottom. However, I already had a turret tutorial package, so it automatically put my mesh into there. So now all I have to do now is, with the turret selected, I'm just going to left click and drag it into our scene. And now I'm just going to maneuver it over here, rotate it 90 degrees so it's just facing relatively near me. And now that's set up, all I have to do now is convert this to a mover or an interactor. By converting it to a mover, you automatically make it an interactor. And the reason why we do this is so that we can animate it in Matinee and also reference it in Kismet. So let's right click on the object, go down to convert, and then convert to mover. And then we can press F4 on the keyboard with the cylinder selected, just to make sure, yep, it's an interactor. So that's good. So now all we have to do, when we usually turn things into from a static mesh to an interactor, it loses its collision, and usually we fix that. But in this case, we don't want to fix it because we're going to be shooting projectiles from within the location of this turret, and if there was collision, the rockets would explode within the cylinder instead of passing through it and firing at the player. So we're just going to leave it at the default with no collision. And now we can go into Kismet and start scripting. So let's open up Kismet. So I'm just going to separate these into two windows. So the first thing we're going to do, we're going to set up a bunch of variables that we're going to need to reference throughout the script. So let's begin with an object variable that will represent our cylinder here. So with the cylinder selected in our scene, let's right click in the empty space of Kismet. Now let's go to new object var using interactor_0. So here we have our object variable. And the only thing we're going to do now is change the var name from none. We're going to change that to turret, because we're going to be making name variables later on. So whatever we give our var names to, that's going to be the name of our name variable, and it'll be able to reference this object variable. Okay, the next object variable we're going to need is going to be for the player. So holding down P on the keyboard, hold that down, left click into the Kismet window, and you'll get an all players object variable. And all we have to do now is uncheck all players, so that we'll get the player 0 object variable, which is us. And then all we have to do now is go down to var name and change that to player. The next set of variables we're going to be creating are going to be floats. These will take care of float values that we'll need to determine the distance between the turret and the player. And one will be for the minimum distance we want to have between the turret and the player before the turret starts firing at the player. So if we make that 1024, once the player gets within 1024 units of the turret, it'll start firing. So let's right click, go to new variable, let's go to float, and then float. So for this one, this is going to be the float variable that we're going to use to determine the distance between the player and the turret, and we'll be constantly updating it because the player will be moving. So as the player moves closer and closer to the turret, this number will get smaller and smaller. So let's leave it at 0 because it's going to be constantly changing. Now let's change this var name to just distance. Now let's copy and paste the duplicate of this variable. So let's do Control-C, Control-V, create copy, and let's change this flip value to 1536, and that value will mean if the player is within 1536 units of the turret, it'll start firing at the player. Now let's change this var name from distance to minimum distance. Now the next set of variables we're going to be using is going to be vector variables. And vector variables hold x, y, and z values that we'll be using to determine the player and the turret's location within 3D space of the level. So let's right click, new variable, let's go down to vector. Now we're going to leave all the values at 0, and we're just going to change the var name to player location. Now let's Control-C, Control-V, a duplicate of this vector variable. And all we're going to do here is change the var name from player location to turret location. And what we'll be using these for is we'll need the turret location to know where we're going to spawn the projectiles from, and we're going to need to know the player location so we know where the projectiles will be aiming for. So that's what we're going to be using those for. So the last variable we're going to need is going to be a Boolean variable that will tell us whether or not our turret is ready to fire or not. And it'll help us control turning off the ability to fire at the player. It's a good way to practice using Booleans as well. So let's right click, go to new variable, bool. We're going to leave the default at false because this variable will hold whether or not the turret is ready to fire. And we don't want the turret to be ready to fire when the level's loaded. We want it to start fire. We want it to become true only when the player is within that minimum distance. So it's going to leave it at false, and we're going to change the var name to is ready. Now that's all the variables we're going to be using. So let's hold Control Alt and then left click, drag a marquee selection around all of these variables to select them all, and then press C on the keyboard to bring up a new comment box. I'm going to comment it as variables. So now we have a clean little box around all our variables, and it keeps it all organized for us. Okay, now that all our variables are set up, let's figure out how to get the player's location and constantly refresh that player location, because the player will be moving throughout the time we're playing in the level. And we're also need to get the turret's location, but we're not going to need to update that because the turret isn't actually going to move in terms of translation, but it will move in terms of rotation, but we don't have to worry about that. So the first thing we're going to do, let's right click, let's go to new event, and then level loaded. And what this event does is once the level's loaded, anything that follows that in the Kismet script, so whatever actions follow this event will fire once the level's loaded. So what we want to do as soon as the level's loaded, we want to get the location and rotation of the turret and the player. Well, we actually only want the location, but the node we're going to use is called get location and rotation. It allows us to get both, but we only want to do location. But that does come in handy if we ever do need rotation. So let's right click, go to new action, actor, get location and rotation. So this first get location and rotation, what we're going to do here is we're going to get the turret's location. So the first thing I want to do is I want to plug in the loaded and visible output of our level loaded event. Plug that into the input of our first get location and rotation, just so when the level's loaded, it'll get the rotation and location of whatever we want as the target. And for this one, we're going to do the turret. So let's create a new named variable that will reference our object variable that then references our interbacter turret. So let's right click, go to new variable, named variable, and then under expected type, let's change that to object. And then for find var name, we called our object variable turret, so that's what we're going to type in here. And then you see we got a check here saying yes, I know what you're referencing, and what we're referencing is this interbacter object variable here. And the reason why we're going to be using name variables just for organizational purposes, we want to only keep one iteration of our original interbacter turret variable, and then just use name variables just to reference that one, just to keep everything organized. So let's plug that into the target. As you can see, it plugs in, and everything's working so far. So now we want to get the location of the turret in 3D space. So what we're going to do is create another named variable. So let's go down, new variable, named variable. And then for this one, we're going to do vector. And then we named our vector variable for the turret location. We called that turret location. Then we got another check mark. So we're going to plug that in. So what's happening here is once the level's loaded, we get the location and rotation of our turret intervector in 3D space, and then those coordinates get placed into our turret location vector variable. And since the turret's only is going to be staying in the same place, we only have to do that once, unlike the player, which we'll have to create a delayed loop for. We'll do that right now. So let's select our get location and rotation node, hit Control-C, Control-V, create a duplicate, and when you create a duplicate of a node that already has variables attached to it, it automatically connects them to the duplicate, but we don't want that right now. So let's hit Alt, let's hold Alt, and then left click on our variable connectors here just to disconnect those variables. And then for this second one, we're going to use the player as our target and then the player location as our location. So let's copy and paste the version of our turret name variable. And since it's already an object variable, all we have to do now is change the find var name to player. And now we have our check mark again, so it's referencing correctly. And now let's copy and paste the turret location name variable. Since it's a vector variable already, all we have to do now is change it to player location. And then we got the check mark once again. So plug that into location. And now all we have to do is plug the loaded and visible output of the level loaded event into the in input of our second get location and rotation node. So now when the level's loaded and visible, it'll get the locations of both the turret and the player, but only once. Wherever those objects are in that instance the level's loaded, that's where the turret location's coordinates are going to be. So wherever our turret is right now in 3D space, that's where its location is going to be in this variable. Whereas where the player is, that's where right here where our player start is. As soon as we load in that, the coordinates of this player start in 3D space will be placed into this vector variable. And once we start moving, this won't get updated as of right now. But what we're going to do now is we're going to set up a delayed loop so that it updates every 0.1 seconds or every 10th of a second. So let's right click on our output of our get location and rotation node that's associated with our player. Let's right click on that, go to set activate delay, and then when prompted, change it from 1.0 to 0.1, so that's every 10th of a second. And now plug the output into the input of the same get location and rotation. So now every 10th of a second we're beginning the player's location. You could update this even more or slower, so if you made it 100th of a second, every 100th of a second the player's location is going to be updated and placed into this player location. And that's going to be very handy for when we're spawning projectiles, because when we spawn the projectile, it will be checking where the player's location is. Since this is updating every 10th of a second, that the projectiles will know every 10th of a second where the player has been. So we'll get a kind of an accurate firing from the turret to the player. So now that's set up, let's hold Control and Alt, and then left click drag another marquee around all this stuff that we just created. Hit C on the keyboard to create a new comment. And let's call this get location and rotation. So now we have that isolated on its own, and it's not going to be associated with our main script. It's just something that needs to happen on the side so that our main script works properly. Okay, now that we have our script getting the location and the rotation of both the player and the turret, we're just getting those locations, but we're using the get location and rotation nodes to get those locations. Now that that's set up, we can move on to the main script of this Kismet script, which will be involving getting the distance between the player and the turret, then from there determining whether or not the player is within the minimum distance that we want between the turret and the player before the turret starts firing, and then from there start spawning projectiles and of course animating the turret so that it tracks the player's movement. So let's start with that. The first thing we're going to do is I'm going to demonstrate to you why the original turret mesh that I used in the first tutorial, I'm going to demonstrate why that doesn't work for this location-based rotation of the turret. So let me first show you how it works with the cylinder that we created earlier. So let me maximize this window. And then having the cylinder selected in our scene, let's right click, go to New Matinee, move this aside, let's double click on the matinee, and then what we're going to do here, with making sure our cylinder is selected in our scene, let's right click, add new empty group, let's call this turret, and then right click on the turret group, and then do add new movement track. And when you create a new movement track, you basically get they give you a starting point keyframe, and then they make the default time 5 seconds, so I'm just going to move this all the way to 1 second. Left click drag this red triangle to the 1 second mark so that the red and green should be matched up. And then I'm going to move this slider. I'm going to move this all the way to 1 second and press enter on the keyboard to make a second keyframe. So now we have a start and end point for our animation. And now that that's set up, we have to create a new blank empty group that represents our player. So let's right click, do add new empty group, and name this player. And then back into our movement track. Down in its properties, you'll see a look at group name, and that is going to be what we're going to be looking at. And what we want to look at is the player. So let's type in player into that parameter. So now we're saying, hey, look at this group, which is our player. And the last thing we got to do here is scroll all the way down, find rotation mode, or rot mode for short, change that from IMR keyframe to IMR look at group. So now we're saying, okay, just rotate based on where the look at group is, and the look at group is where the player is. So now we're just saying, okay, just rotate wherever the player is. So that's set up. That's all you have to do for this matinee. So let's exit out of matinee. Now let's clean up our matinee node a little bit. So let's delete interactor_0 just because we have our name variable for turret just to reuse it. So let's copy and paste a copy of our turret name variable. Plug that into the turret variable connector of our matinee, and then do the same thing for the player. Let's copy and paste the player name variable, and let's plug that in to the player variable connector of our matinee. So now the last thing we gotta do here is we gotta make sure that it's looping. And if we don't change it to looping, when it follows the player, you'll get hiccups in its rotation. So like turn, stop, turn, stop, turn, stop. It'll be really fidgety, and we want to have a really smooth transition as it rotates. So that's why we need it to loop. And now to check to see if this is working, let's just create a new event for level loaded and just plug that into play. So now let's jump in, and as you can see, it's looking at us, which is exactly what we want. So that's working. So now let me quickly demonstrate to you why the original turret mesh wasn't working and how we can't fix that from what I can tell. So let's go to our content browser, and on the side here look for vehicles under UT3 and then hit the static mesh filter. Now let's scroll down until you find S_VH_cicada_DMG_01F. That was the turret mesh that we used in the original turret script video. So let's drag that into our scene. Let's just maneuver it a little bit. Let's have it facing the same way as our turret. So now you would think it would follow us the same way the cylinder has been doing it, but it doesn't. So let's first convert this to an interactor so that we can reference it and let it animate. So let's go down to convert to mover, and then back in Kismet, let's create a new object variable for it. So go with it selected in the scene, let's do new object var using interactor_1, and let's also just plug that into turret. So now they'll both rotate looking at us as the player. So let's go in. So as you can see, the center, well, not really the center, but the wrong side of the turret is looking at us. And the reason for it is because of the pivot and the rotation of this turret mesh in 3ds Max or Maya, whichever one it was created in when UT3 was made. That was done incorrectly for our purposes. And we can't fix that. We can't export this mesh to file. We'll get an error saying the data is not available. And the reason for that is because all the mesh data and texture data and all that data is cooked into the engine, meaning you can't extract that data and make it an FBX or an OBJ. You can't export it and then bring it back into 3ds Max and then make the necessary changes. So that's why I made this cylinder. So whenever you want to make a new turret, if you're actually a modeler or you do have access to 3D artists, make sure they make the pivot point on the correct side, and they make sure it's rotated in the same direction as my cylinder was in 3ds Max, so you'll get the same rotation as I am. So let's delete this turret mesh, and this will remove it in matinee. And let's also get rid of the level loaded event because we want this to activate only when the player is within the minimum distance of the turret. So let's move that aside. We'll plug that stuff in later when we need it. So the first thing we're going to do is we're going to create a new level loaded. Let's go to new event, level loaded. And the first thing we're going to do is we're going to get the distance between the turret and the player, and we're going to be constantly refreshing that distance because the player will be moving away or towards the turret at all times. So let's right click, go to new action, actor, get distance. So this basically takes two inputs for the object. So we're going to compare A to B and then get that distance and place it into a float variable. So A and B will be the turret and the player. So let's get a copy of both those named variables from our already made named variables within our script. I'm going to plug turret into A, and then I'm going to plug player into B. It doesn't really matter which one you do for either or. So let's plug that in. And then for distance, let's create a new named variable. So let's go to new variable and named variable. And then expected type, let's change that to float. And then for find var name, we named the one we need is distance. And we got the check mark saying, yeah, we know what we're referencing. So let's plug that in. So now we get the once the level's loaded, let's plug that into the end of the get distance. So once the level's loaded, we'll get the distance of the turret and the player, and then that distance will be placed into this float variable. But the problem is it will only fire once. So as soon as the level's loaded, we'll get the distance between the player and the turret, but that distance won't update as the player is moving towards or away from the turret. And we gotta create another delayed loop like we did for this get location and rotation of the player. And we're gonna do that every 100th of a second, because we want to get that updated as much as possible. So let's right click on the output of the get distance node, set activate delay, and let's change this to 0.01 or 100th of a second. And then let's plug it back into the in. So now every 100th of a second we'll get the player's distance, and then that distance is placed into this distance float variable. So now what we want to do is we want to compare the player's distance to the minimum distance that we set in our minimum distance variable, the 1536. We want to compare that 1536 to the distance of the player from the turret. So if the player is within that 1536, meaning it's less than 1536, we want the turret to activate and start firing at the player and animating and so forth. And then when it's outside the range, we want it to stop firing. So let's right click, do new condition, comparison, compare float. I'm going to plug this down here, and I'm going to plug a new instance of our loaded and visible output into the in of the input, just so we only let it fire once, and we'll loop it in a little bit because we also need to loop this so it constantly compares these two floats. So the first thing I want to do is I'm going to plug in distance, this float variable right here, Control-C, Control-V, a new instance of it, and plug into A. Now I'm going to copy another version of distance, but I'm going to change it to minimum distance, making sure we get the check mark as well. I'm going to plug that into B. So now we're comparing the distance between the player and the turret, and we're comparing that to the minimum distance we set before, the 1536. So now we're going to do a few things first to move on from here. The first thing we're going to do is we're going to set the isReadyFire variable to either true or false based on one of these conditions here. So first we need to get the set variable node. So let's go to new action, and then down here is set variable, and then bool. So now the first instance of this, the target, is going to be our isReadyBool. So let's create a new name variable to reference that. So new variable, name variable, expected type, let's do bool, and then find var name is ready. And now we have a check mark, so it knows it's referencing the right thing. So we could change this to plug it into target, and then for value, the first value we're going to do is we're going to do false. So let's go new variable bool, and the default's false, so that's why I want to do that one first. So let's plug that into the value. And so now we're having it, so based on one of these conditions, we want to set the isReady variable to false. And in this case, we want to set that to false only when the player is outside of the minimum distance range. So we want to plug in if A is greater than B, meaning the distance between the player and the turret is greater than the 1536, meaning it's outside that range. So let's move this up here, and let's plug this into the input here. So this is saying Okay, let's compare these two floats. If distance is greater than minimum distance, set this variable is ready to false. So now let's marquee select all the set variable stuff here. Control C, Control V it. And all we're going to do now is change the false variable to true by changing the B value from 0 to 1. And so now when we want this to be true, meaning we want this turret to start firing, is when A is less than B, meaning the distance the player is between the player itself and the turret is less than the minimum distance, meaning we're within that 1536. So let's plug that in here. So A is less than B, plug that here. So now that's set up. So now we want to create an infinite loop here. Not an infinite loop, we want to do another delayed loop. So let's plug in the output of both these set variable nodes. Let's plug those into the input of the compare float. And now if we didn't put a delay here, we'll get a Kismet script warning when we play saying there's an infinite loop. So let's create a new activate delay, do 0.1. So now if A is greater than B, we set the is ready variable to false, and then after a 0.1 second delay we check again to see how these two compare, and we also do the same thing once A is less than B. So now what we want to do is now we want to compare the is ready Boolean variable and see if it's true or false, and based on whether it's true or false we want certain actions to fire. So if is ready is true, we want to animate the turret by playing the matinee, and then from there we want to start firing at projectiles at the player. But if the is ready is false, we don't want any of those things to happen. So let's get a new condition comparison, and then we're going to compare a bool. So the bool we're going to compare is the is ready boolean. So let's create a copy of it and plug it into bool. We're also going to plug in both set variables, their outputs, into the input of the compare bool. And now what we want to do, let's get our matinee and all the variables associated with it. So if this is ready is true, we want to start playing the animation, meaning that the turret will start tracking the player's location and rotating based on that location. So let's just jump in really fast to see if this is all working. And if it is, we'll be able to tell. As soon as we walk close enough, the turret will start following our location. So let's see. So as you can see, it's not looking anywhere, and then we enter the 1536. So that's working, which is great. So the next thing we're going to do is I'm going to create a new trace, and what a trace does is that it sets a ray trace between two objects, and if there's an obstruction, we're allowed to do certain actions if there's an obstruction, and if there isn't an obstruction, we're also allowed to pass on actions from there. So let's do a new action, misc trace. So here's our trace. We have a start point and we have an end point. The start point is going to be our turret, and our end point is going to be our player. So there's going to be a ray trace shot from the turret to the player. And if it's obstructed, we can do something, and if it's not obstructed, we can do something. So first we need an input, and it's going to be a level loaded, so let's create a new version of our level loaded event just so we don't have one plugged into a lot of different actions. Hold Alt and then left click to get rid of anything connected with our level loaded, our new one. And then let's plug in loaded invisible into in of our trace. And then let's find copies, let's create copies of our turret name variable, plug that into start, and then let's create another copy of our player name variable, plug that into end. So now what we want to do is we want to have another delayed loop within our trace so that there's a ray trace being shot every 10th of a second, so that basically the turret's going to be checking if it can see the player every 10th of a second. So let's right click on both not obstructed and obstructed, these variable outputs, not variable outputs, just normal outputs. Right click on these, set activate delay, do 0.1 for both. And then plug both of these back into the in of the trace. So now every 10th of a second, it's going to be checking if there's an obstruction between the player or the turret. So now what we want to do here, we want to create a gate. And a gate basically says we can pass in two different conditions, and if both are true, then we can fire new actions. So let's create a new gate. Right click, new action, misc gate. By default, the gate's open, meaning true. So we want to change that to false. We don't want it to be open right away. We only want it to be open once the player's within the minimum distance and there's no obstruction. So let's plug the true into the in of our gate, and then the not obstructed into the open. So basically we're saying, okay, once the player's within the minimum distance and is ready is true, and there's no obstruction, we can do something, and that something is going to be firing projectiles. So we also want to have conditions in place that closes our gate and allows us to stop firing at the player. And that's where our false and our not obstructed come in. Our false and our obstructed come in. So let's plug in our false into close, and then our obstructed into close. So basically, if the is ready is set to false, meaning the player is outside the minimum distance, we're going to close the gate, and when the gate's closed, nothing past it will fire. So all we have to do now is set up the ability for the turret to start firing rockets at us. So let's right click, go new action, spawn projectile. So the first thing we're going to do here is we're going to set up our instigator. For some reason, the instigator has to be a blank object variable. I'm not sure why this is true, but it is. If you were to put in the player, for example, as our instigator, the first rocket will do damage on the player, but any rockets after that point will not. I'm not sure what causes that, but the solution is a blank object variable placed into our instigator here. So let's right click on that variable connector and do create new object variable just to create a blank one. And now our spawn location, that is going to be a named vector variable that will represent our turret location. So let's right click, new variable, named variable. Let's go down here, change it to vector, and do turret location. And then we have it checked, and let's place that into spawn location. Now for target location, that's going to be our player location. I forgot we had these already created, so let's just go down here, create a copy of our player location, drag it up here, and plug it into our target location. And then let's click on the spawn projectile itself, and then under projectile class, let's do rocket. So now we're choosing rockets are going to be firing at the player. If you have your own unique weapon types, you can spawn your own projectiles here, or you can choose any one of these given to you. I'm just going to do rocket. So let's plug the output of our gate into the input of our spawn projectile. And now we're going to create another delayed loop, so the rocket projectile is spawned every second. So let's right click on the output, set activate delay, leave it at the 1 second default. And then I'm just going to shoot this over to the input of our compare bool. So once a rocket's fired, it's going to compare the bools again. If it's true, it'll pass back into the spawn projectile and fire again. So let's select everything I've done here. Let's move it a little bit of ways away from people. Press C on the keyboard to get a comment, and then just going to type in main body, just so we know. And that concludes this tutorial, at least in the scripting part. Let's just check if it works. As you can see, it's working, but it's kind of firing faster than 1 second. And the actual solution here is going to be in our delays here of our set bools. So let's set those to 1 second instead. Let's go back and see if that worked. There we go, that's 1 second apart. Alright, so that concludes this tutorial. Let me just start building lighting so I can conclude the tutorial. So what I've shown you here is basically the same turret script tutorial as before. I didn't go over damage because that went over in the other tutorial. So if you want to learn about how a turret takes damage and let it get destroyed, watch the other video. I'll have it in the description below. I also have a note at this point in the video you can click on to get a link to it. We learned how to get the rotation based on location using the matinee, the look at group in matinee, and then the rotation mode to do the look at group. So that finishes this tutorial. I hope you learned a lot. This was definitely a nice learning experience for me. A nice shout out to Dom Ridley for asking the question. I hope this answered it. I had a lot of fun working on it, and I hope you have some use for it. Definitely check out my portfolio in the description below. Also check out the projects I'm working on. Please like this video, comment on the video, subscribe to my channel for more tutorials, and please comment asking for more content. I'm always thinking of new things to go over, but if you have any questions like Dom did, I'll be more than happy to look into it. If I find a solution, I'm going to create a video for it. So thank you for watching, and I hope you learned a lot.